Hey everyone, Matt from Workshop Tinkers here. Today we're going to go back to 3D printing basics, specifically extruders, as you can see well, below you from my perspective, but in front of you on your computer screen. So what we're going to talk about today, real quick, just some extruders, things to consider, different types. These are in front of you are ones I've used, some quite recently, other than E3D. I just got it today. It's going on the printer right after I'm done with this video. Other than that, extruders, what do they do? They are what actually pushes the filament of your 3D printer into the hot end, some way, shape, or form. Okay, nice and simple explanation. There's two main types, well, two sets of categories. Each category has two items each. You have your direct extruder and you have your Bowden extruder. What I mean by this is my old direct extruder that came with my printer, the Wilson 2, Rep Wilson 2. Oops, that fell out. Anyways, it mounts on the printer in my perspective like this, but this filament goes down, and the hot end actually attaches to the bottom here. So it moves, in this case, on the X direction, back and forth. It works quite well. The only problem I ever had with it is it doesn't work with flexible filament. There's not quite enough room. If I drilled out that bottom hole there and put some Bowden tubing, which we'll get to Bowden tubing in a little bit, it might have been able to. It's quite tight down all the way through to where it enters the hot end. If I drilled that out and changed it, it probably would have worked quite well. Obviously this one's missing parts and no longer has the hobbed gear. The other side of that, as I mentioned, is the Bowden extruder. What Bowden is the piece of tubing, just like this one, that the filament passes through between the extruder and the hot end. Why is this beneficial? Well, there's a few reasons. One, it simplifies your hot end. You don't have to have a motor and extruder sitting with the motor. Now, removing the motor will remove weight, possibly reducing ringing, though in my experience, but it does make it simpler. If you're trying to get a lot of stuff in a small space, not having this big motor in the way might help. Now this one, obviously you can see I'll let you know the design right there. You can see that spot. That's where my hot end fan went on. The part cooling blower. It worked great. Now I've modified my printer from it was a rather rack and pinion type Z sensor to BL Touch. Why? Because the rack and pinion actually snapped. I've put probably 2,000 hours on that machine at this point, maybe more, but it broke. But I'd already swapped away from this hot end at that point. Now Bowden, you have a number of different options. My favorite, or was my favorite, it's actually started giving me issues recently, is what is known as the simple Bowden extruder. What this is it has this one specifically is a Mark 7 hobbed gear, for lack of a better term. It pushes filament in one through this gear right here and out the Bowden tube that goes into this pneumatic film fitting. And this particular one, if you can see, there's actually 3D printed tubing in there to get that as close to the hob gear as possible. Allows flexible filament to go in there. As you can see, there's this larger circle. That's where most of these end, and you can put tubing in there yourself. I've done it both ways. It both works. My last one broke, and I found this model on Thingiverse and figured why not. Now, so we're talking about both direct and Bowden, and one of the benefits of no longer having a heavy weight on your hot end reduces ringing. Now, on the other hand, so the other category is straight drive, meaning the stepper directly drives the hob gear, Or you have one like this. This is my old geared extruder. This was also a Bowden. There's the fitting right there. And it has a, I want to say 16:1 reduction, if I remember right off the top of my head. I don't remember. Puts a lot more force on that filament. Why do you want more force? Well, if you're doing something that might take more force, plastic that needs to go through cooler but needs to be forced through really fast. Also, the gear reduction means either you can remove micro steps from the stepper driver, or you get finer resolution on your extrusion. For example, the Mark 7 here, it's about a 105 steps per millimeter at 16x micro stepping. You do the math, figure out what it is without micro stepping. I'm not going to do it. I'm not going to divide by 16. What does that mean? The smallest I can do is 1/105th of a millimeter, which in all honesty is probably more resolution than you'll possibly ever need. Downside of a geared motor is I think I was losing some steps just due to how many it was having to do. This was something like 400 some odd steps per millimeter, and I kept having under extrusion issues, and I kept feeling like it was failing because of that. The E3D, same thing, except I want to say 16:1 as well. It uses, instead of 3D printed gears, it uses these little tiny things here. Next thing I wanted to talk about, so that's Bowden versus direct and straight versus geared. Fantastic. All options you have. Now, something you need to think about is this right here, and I'll just kind of point to this here. These are your driver gears. This is the Mark 7, the Mark 8. I don't know Mark 8, 7, Mark 8 what. You search eBay, Amazon, Alibaba, whatever for a Mark 7 gear 3D printer part. This is what will come up. Mark 8. They're virtually identical, just different diameters. They are hobbed. Hobbed is a way of removing material, making fine teeth on gears and other gear-like parts. They're a bit cheap. You can tell, especially this particular Mark 7, the teeth aren't great. But they're not bad. 105-ish steps here per millimeter, 150 or so here. Look it up online how to figure out what your ratios. That is, of course, assuming a 200 step per revolution stepper motor and 16x microstepping, the quote-unquote standard stuff. Fantastic parts. I like these. The Mark 7 is my preferred over Mark 8. One, the larger diameter means more teeth are engaged on the film at any given point of time. I also like for that cutout, there's a half moon of material gone. That's where the filament sits down. I can use then flat pulleys, flat bearings to press the filament up against that. I found with the Mark 8, as it is like this with just a flat bearing against it, it would lose grip quite easily. And I'd have a lot of filaments skipping issues. Another option that you'll find, especially in Chinese extruders, is like this one here. This is just a cheapo old style. They did make an improvement. I'll show you what the improvement is shortly. Old style Bowden extruder. And you can see straight teeth on this thing. It's actually using a pulley that has a half moon cutout, the semicircle cutout that gives you the place where the filament goes to keep it on track. I never liked this. I used it twice. I never got it to work properly. It felt gross. It was squishing the filament. I didn't like it. I didn't have much success. I'm sure a lot of people out there have used it, have had a lot of success. But this is where I found out one of the difference between a 3D printed extruder and a even cheap metal extruder is I've gone through a good half dozen of these over the last couple of years, where the plastic on this one you can't really see, but the plastic around this pneumatic fitting is just broken. A lot of times I'll have fittings where it goes, the screw goes through to attach it to a stepper, break, and things just start flopping around and breaking. And the metal, I mean, metal is metal. It's going to hold up better, especially for 3D printing, which isn't all that rough. Now this is the extruder I found when I went on recently. It's an upgrade to this as far as I can tell. It's a very similar design, but it's got a Mark 8 hob gear, 2 of them, with a gear in between that mesh together that the filament passes between. I've put about 40 to 60 hours, I've lost track exactly, of print time on this part. Hasn't skipped once, and once I got it tuned in, it's a little bit, well, I had to do some fine tuning. It actually is a Mark 8 because it's 150 steps per millimeter, bang on the nose. It works fantastic. It's metal, it's not 3D printed, it's pretty easy to load, which that is important in my opinion, the ability to load these things, because I don't know about you, I'm flopping filament around all the time to change colors, if not materials and other things. I quite like this thing, and for somewhere in the range of $15 to $20, fantastic. Now, when I was shopping around trying to find a new extruder, this thing was frustrating me. I didn't want to do the geared anymore. It frustrated me as well. I found the E3D. But real quick before I talk about that, back to the geared extruder. This one is the oddball in that, actually if I take it so that you can see in there, it is not a hobbed gear. It is a hobbed bolt. I'll take it apart so you can see the hobbing in there, and that is integral all the way to the end. This is a solid bolt that goes all the way. I want to say this is a 8mm hob bolt if you want to look for it. Works great. The only problem, the reason why I moved away, one, I thought I was getting skipped steps, and two, this part just, it's not holding up well longevity wise. You have to use the flange bearings, even though I believe the instructions didn't tell you to, and then it would just, it's cracking, it's breaking, whatever. Back to my original point of 3D printed parts versus non 3D printed parts. I put enough hours on my printer in the same configuration without changing it that things just wear out. Now the E3D, this is a little bit different. It's getting back to the direct drive. You can, same part, this is the Titan by the way, the E3D Titan. Depending on either you get the Bowden adapter like I have it in here, or any of their V6 hot ends, either the light with the PTFE tube in it or the all metal hot end, the V6, they fit in this spot right here, which means you can have a small little compact extruder right on your hot end, and you actually have to have a mount in there for it to work. It's fantastic again. Now I haven't tried it yet. I'm going to do Bowden for a while I try to figure out a design for the mount so I can do the BL Touch and figure out a fan cooling solution for my printer. So it's going to, you know, mount like this on my printer. The tubing is going to come up and over, and it should have quite high extrusion. It has one of the best looking hobbed gears I've seen, period, but it's also probably the first one that I've seen that is an actual name brand, not Chinese knockoff. I can't remember, I think they call it the Hobgoblin or something like that. I'm really looking forward to, as soon as this video is done, this is going on my printer. Now, something else that you want to think of with direct versus geared, if you want to have, or straight drive, geared drive, direct, something else you have to think about is weight. as I said before. Now you can see here, standard quote-unquote NEMA 17 stepper motor. This is just, this one is automation technology. Okay, it is, I don't remember the exact specs on it, but it's what you consider a standard NEMA 7. It's, you know, in the $15 range, $10 to $15 on Amazon, eBay, wherever. 200 steps per revolution, whatever. It's got a decent weight to it. Now this is E3D's compact but powerful motor. This is a 400 step per revolution motor. And look at the size difference there. Though supposedly this one will put out almost as much torque as this, and by the specs it's, yeah, 1.46 amps versus 1.6. It's darn close versus, say, a pancake stepper. This is 0.7 amps max draw. It's not going to have nearly the holding power of either of these, but if this thing's moving back and forth with your hot end, there's going to be a lot less weight. So I might try at some point slapping this in here instead of that part, the compact but powerful part, and see, you know, maybe it'll be the perfect thing for me. Now, there is one thing I haven't shown you right here because I don't have it. And yes, those of you who are 3D printing people will probably notice I'm a bit of an E3D fanboy. Their stuff works for me, so I stick with it. I've been doing some research, obviously, since I just bought this Titan. They have both the Titan Aero, the Titan Aqua, and then the what's it called, the Hermana. But either way, they're integral extruder hot ends. Meaning, instead of this extruder here and the hot end comes out the bottom and sticks out, you know, the 1.5 to 2 inches, the hot end is only about half an inch further down, and there's a big old heat sink here for the hot end heat sink to keep the heat from going into the rest of the part. The Hermana, or however you pronounce it, is basically the same thing. It's just an all integrated, you know, you can only use the one stepper, but really nice looking, where it's barely longer than this is tall, and the weight on it is entirely dependent on the motor. But one of the things I find is, because the stick out of the hot end, that's just a lever, and any issue you have is just going to start getting that thing wobbling around. Is to think about ringing. But I haven't tested it. This is going on my printer right now. It's going to get its paces put through it. You probably won't see a review on it because I don't think anybody really cares about my opinion on the reviews. Things to think about. I run Bowden because of what I said, ringing and ease of hot end movement. There's no good or bad, just do what you want. I hope this was informative. I hope this helped you understand if you're thinking about changing hot ends, or you trying to, or troubleshooting a problem maybe. Things to think about. Hope everyone has a great day. Keep tinkering. Catch you on the next one.